The second part of 6.1 is about arc length and area of a sector. I don't know why I decided to do a green background this time, but I did. So we're going to talk about arc length and area of a sector of circles. And the big key here is that angles have to be in radians when we're doing this. So if I ever give you an angle in degrees, you have to make sure you change it to radians. So we are going to find S in this situation right here, and S stands for arc length. I don't know why S stands for arc length, but this means arc length. So I want to find the arc length of a central angle of 128, so that's this, and that's in degrees, and the radius is 5, and that's this piece here. So the formula that you need to know is S equals R theta, but R always has to be in radians. So the first thing I'm going to do is take 128 degrees and change it into radians. So I never have my calculator on my screen because explain everything doesn't do that. So let's see, 128 divided by, let's see, so I'm going to do this the long way. So this is what you could do as well. Half of 180 is 90. You can divide these by 2 again, so 32 over 45. And I don't think I can go any farther with this, so see, you can do it without a calculator, just kind of keep dividing by 2. So 32 pi over 45 is going to be my degree. It's not my degree, my radians. So arc length equals radius, which is 5, times theta, and my angle is 32 pi over 45. So I'm going to do this with a calculator again, because 45 is 9 times 5, so I can cancel those out, and I get 32 pi over 9, and that would be centimeters. I couldn't quite squeeze it in, but centimeters would be the way to answer this. This is how you find the arc length of a circle. All right, so here we have area, and I gave you the formula for area, but again, that theta has to be in radians. So I want the area, and if I colored this in for you, it would be this chunk here. I'm going to find the area of this circle, and the formula is going to be 1/2 r squared theta. Well, I gave you theta in terms of radians this time, and you know because it doesn't have that degree symbol, but also because it has pi in it. So area equals 1/2 11 squared times 3 pi over 7. So what do I have here? This is 144. It's 3 pi, and 7 would be on the bottom. How can we reduce this? Well, I'm not sure that we can. So 144 times 3, okay, you might need a calculator here, is 432 over 14, and those can each be divided by 2, so let's try that, 216, and that might be my final answer, 216 pi over 7, and that would be then, they didn't give us a unit, but that would be units cubed, because we're talking about area now. So it says, what does it mean when it says exact answer? So some of us have been struggling with this. Exact means that there's pi in the answer. Accidentally chose the highlighter. I'll go back to the pen. There's pi in the answer. No decimals. Okay, there could also be square root in the answer. Okay, so if you get the square root of 10, it stays square root of 10, not a decimal. Okay, so you just leave it like this. Formulas that you might need: an area of a circle is pi r squared. Circumference of a circle is 2 pi r, and I think I gave you all the other formulas, and that should be everything you need.